We are the group, and today we are going to present the activity number 7, titled Reaction Stoichiometry. So I'm going to give the floor to the first reporter.
So, good morning, everyone. So, we are group 3 and we will be presenting reactions Decomposition. Next slide, please. So, our objective for today is to know how to identify or write possible molar ratio, learn how to convert depending on the amount of given substance to the amount of unknown substance, then master the calculation and understand the stoichiometric calculation. Next, please. Then, what is reaction in stoichiometry? The calculation products of reactants in a chemical reaction is crucial concept in chemistry. It helps us to use balanced chemical equation to calculate amounts of reactants and products. It predicts how much of reactant participates. Wait lang, Bri. It predicts how much of the reactant participate in a chemical reaction, how much product you'll get, and how much reactant might be left over. Since prediction is one of the main goals of science, reaction in stoichiometry is a big help and able to explain phenomena we observe in a natural world, such as farmer determining how much fertilizer to use. Next slide, please. So chemical formulas provide the identities of the reactants and products involved in the chemical change, allowing classification of the reaction. Problems such as given and unknown quantities or amounts in moles, given in amount in moles, and unknown is a mass that is often expressed in grams, and given is a mass in grams, and unknown is amount of moles. When you are given the amount of substance in moles and asked to calculate the amount in moles of another substance and chemical reaction, the general plan is amount of given substance in mole, then amount of unknown substance in mole. When you are given the amount of one substance and asked to calculate the mass of another substance in a chemical reaction, the general plan is amount of a given substance in mole, amount of unknown substance in mole, and another amount of unknown substance in mole. Next slide, please. So when you are given the mass of one substance and asked to calculate the amount in moles of another substance in a chemical reaction, the general plan is mass of a given substance in grams, amount of unknown substance in mole, another amount of unknown substance in mole, then mass of unknown substance in grams. Next slide, please. So mole ratio will be discussed by Ms. Stephanie Villanueva.
Good morning, everyone. For the mole ratio is a conversion factor that relates the amount in moles of any two substances involved in a chemical reaction. So we have here an example. We have aluminum oxide. Our product is aluminum oxide and our reactant is aluminum and oxygen. Next. What we are going to do is to write all of the possible mole ratio. But if we were asked to write the given mole ratio, we will just be looking at the specific coefficient with the given problem. But for here, since we are asked to write all of the possible mole ratio, we will write all of them. So we have here 2 moles of aluminum oxide over 4 moles of aluminum, or we can just ibaliktad. The next is 2 moles of aluminum oxide over 3 moles of oxygen, or again, ibaligtad. And the last one is 4 moles of aluminum and 3 moles of oxygen. We only have 6 possible mole ratios since we only have 2 reactants given and 1 product. For the decomposition of aluminum oxide, the appropriate mole ratio would be used as a conversion factor to convert a given amount in moles of one substance to the corresponding amount in moles of another substance. To determine in moles of aluminum that can be produced from 13 mole of aluminum oxide, the mole ratio needed is that of aluminum to aluminum oxide is 13 mole of aluminum oxide multiplied to their mole ratio, which is 4 moles of aluminum over 2 moles of aluminum oxide, and that will be equal to 26 moles of aluminum. To proceed with molar mass, I will be giving the floor to Ms. Umila.
Narinig po ako, ma'am.
Marinig ka, Umila.
Ay, okay, thank you. So for the molar mass, when we talk about molar mass, we're usually referring to the amount of a substance present in a given amount of a substance. This is usually expressed in grams, but we can also express molar masses in another format, kilograms. This is because the molar mass of a substance can be expressed using a conversion factor. In this case, the molar mass is equal to the mass in kilograms divided by the substance molecular mass. So the process of finding a substance molecular mass involves a series of steps. The first step is to find how much material is present in a given amount of a substance. The second step is to find the number of grams of material in a given amount of a substance. And lastly is to find the grams of material in a given amount of a substance. So for the next reporter, we have Ms. Plantig and Ms. Paredes.
Hello po, ma'am. Audible po ba ako?
Yes, you may continue.
Next slide, please. Next slide. So for the ideal stoichiometric calculation, it is a solution plan for problems in which the given and unknown quantities are expressed in moles. So as we can remember, we are taught of the patterns for solving stoichiometric, right? And one of those is included kapag moles yung given, then moles din yung ginahanap. Yung need lang natin is yung given and the mole ratio. So we have here the conversion of quantities in moles, which is the amount of given substance, and then times with our mole ratio, it is the mole of unknown over the mole of the given. So we can obtain the amount of unknown substance. So we have here the example. In a spacecraft, the carbon dioxide inhaled by astronauts can be removed by its reaction with lithium hydroxide according to the reaction. And the reaction below is already in a balanced equation. Next slide, please. So the question is, how many moles of lithium hydroxide are required to react with the 20 mole carbon dioxide, the average amount inhaled by a person each day? So our given is the amount of carbon dioxide, which is 20 mole, and the unknown is the amount of lithium hydroxide, which is expressed in moles also.
So the correct the correct ratio has the following units, which is the our mole ratio, the mole of lithium hydroxide, and mole of carbon dioxide. So the next slide is discussed by another reporter. Thank you po.
So this ratio cancels mole of carbon dioxide and gives the units of lithium hydroxide in the answers. So our formula is mole of carbon dioxide times 2 mole of lithium hydroxide divide 2 mole of carbon dioxide and equals to mole of lithium hydroxide. So for the substitution, we have 20 mole of carbon dioxide times 2 mole of lithium hydroxide divided by to 1 mole of carbon dioxide is equals to 40 mole of lithium hydroxide. The equation shows that twice the amount in moles of lithium hydroxide reacts with carbon dioxide. Therefore, the answer should be 2 times 20 equals 40. Next slide.
So I am the next reporter, and this is on the activity part. So let us write all the possible mole ratios. So we have our first chemical equation. We have 2 moles of mercury oxide will to produce two moles of mercury will react to 1 moles of oxygen. So our possible mole ratios here are 2 moles of mercury oxide and 2 moles of mercury. And we have 2 moles of mercury oxide over 1 moles of oxygen. And we have 2 moles of mercury over 1 moles of oxygen. Or 2 moles of mercury over 2 moles of mercury oxide. We have 1 moles of oxygen over 2 moles of mercury oxide. And last one, we have 1 moles of oxygen over 2 moles of mercury. And for our next chemical equation, we have 4 moles of ammonia will react to 6 moles of nitrogen oxide will produce 5 moles of nitrogen plus 6 moles of water. So we have possible mole ratios here. We have 4 moles of ammonia over 5 moles of nitrogen. And we have 6 moles of nitrogen oxide over 5 moles of nitrogen. And we have 5 moles of nitrogen over 6 moles of water, or we have 5 moles of nitrogen over 4 moles of ammonia, and we have 5 moles of nitrogen over 6 moles of nitrogen oxide, and we have 6 moles of water over 6 moles of nitrogen oxide, and we have 6 moles of water over 5 moles of nitrogen. And I'm going to give the slide to the next report.
So next slide, please. So for the problem number 1, we have here ammonia is widely used as fertilizer and in many household cleaners. How many moles of ammonia are produced when 6 mole of hydrogen gas react with an excess of nitrogen gas? So the first thing we're going to do is to balance the equation. So next slide, please. So we have here hydrogen gas plus nitrogen gas will yield to ammonia or NH3. So this equation is clearly not balanced, therefore we are going to balance it. So we are going to place 3 at the hydrogen gas and 2 for ammonia. And now that the equation is balanced, we can now proceed in the calculation. Next slide, please. So the given here is 6 mole of hydrogen gas, and we are asked to find the mole of ammonia. So the formula that we are going to use is molar mass times mole ratio. So we're just going to substitute the given, which is 6 mole of hydrogen gas times the mole ratio of ammonia, which is 2, over the mole ratio of hydrogen, which is 3. Then do the math, 6 times 2 divided by 3, which will give us the result of 4 moles of ammonia. Next slide, please. For the problem number 2, we have here the decomposition of potassium chlorate is used as a source of oxygen in the laboratory. How many moles of potassium chlorate are needed to produce 15 mole of oxygen gas? Next slide, please. So again, the first thing we are going to do is to balance the equation. So potassium chlorate or KClO3 will yield to potassium chloride plus oxygen gas. So again, the equation is clearly not balanced, therefore we are going to balance it. So we are going to add 2 for potassium chlorate, 2 for potassium chloride, and 3 for oxygen gas. And now that the equation is balanced, we can now proceed to the calculation. Next slide, please. The given here is 15 mole of oxygen gas, and we are asked to find the mole of potassium chlorate. Just like the previous problem, we are going to use the formula molar mass times mole ratio. So substitute the given, which are 15 mole of oxygen gas times the mole ratio of potassium chloride, which is 2, and 3 for the oxygen gas. So 15 times 2 divided by 3 will give us the result of 10 moles of potassium chlorate.
So for the conclusion, while we were doing this activity, we learned that the quantities of the reactants and the product in a stoichiometric chemical reaction are such that all of the reactants are consumed and none remain after the chemical reaction is completed. Stoichiometry is important for determining the proportion of the chemical reactions, such as those that occur during corrosion. Furthermore, stoichiometric calculation allow us to calculate the maximum quantity of product that may be created in a reaction when the reactants are not pure or when byproducts occur in addition to the predicted products. It takes practice to solve stoichiometric problems.
And that's for our report, ma'am, for our group.
Okay, thank you for that. Balik sa balik. Let's check. Let's check for the stoichiometry. This one is like an extension of our lecture class. I hope by now you have already familiarized or even memorized our pattern for reaction stoichiometry. So I have already given that for a couple of times now. Yung ating weight in grams times the molar mass times the mole ratio times the molar mass of the unknown in the problem. So this is still it. Actually, the introduction part is about the pattern. It's just that for the activity, paki-move doon sa ano mismo, activity proper na talaga. Ayan, yung write all the possible mole ratios. You just have to enumerate everything, class, that can be partnered in the equation, ha? Yun lang talaga yung gagawin natin. But you have to make sure first that the equation is already balanced. So just like this, the decomposition of 2 moles of mercury oxide will give us 2 moles of mercury and 1 mole of oxygen. And that is considered 1 mole of oxygen, ha? So i-partner lang natin siya to get the mole ratio. So the first one here, we have 2 moles of mercury oxide. Partner natin siya dito. So 2 moles of mercury or the reciprocal of that. So we have here, pwede natin kasi siyang baliktarin, di ba? Remember, depende lang siya sa hinahanap sa problem. So you may have also 2 moles of mercury is to 2 moles of mercury oxide. And then this one also can be partnered with the other product, which is oxygen. So the same thing, 2 moles, so this is check, this is also check. 2 moles of mercury oxide is to 1 mole of oxygen. This is check. And then the reciprocal. Okay, 1 mole of oxygen to 2 moles of mercury. And lastly, hindi lang siya product and reactant, but you can also partner the product and another product. Actually, if dalawang reactant dyan, pwede pang dalawa. Pwede din yun siya, reactant and reactant. So 2 moles of mercury is to 1 moles of oxygen, and the reciprocal. So these are all the possible mole ratio. So I hope you have identified this in your submission. Dapat lahat sila ha. Kasi I'll be giving points for all the mole ratios here, the possible mole ratios for this certain chemical equation. Do you have questions regarding this or clarifications? Wala. This is not really a very hard one. You just really have to identify the possible mole ratios. But let's have the number 2. Okay, so this one medyo mas mahaba ito. Bakit? Kasi you will have 2 products and 2 reactants also. So let's see if you have properly identified everything. Where is my pen? Susulat na talaga ako using my pen. So let's see first if this is already balanced. This is already balanced. And hydrogen, oxygen. 4, 10, and the other side 10. Hydrogen, 12. And the other side you also have 12. Oxygen, 6. And the other side 6. Okay, so this is already a balanced equation. So first, let's start with ammonia. Ammonia to NO. So that's 4 is to 6. Let's look for it. Asa na siya makitaan? Ammonia and NO. Wala? That, can you, wala no? Hindi nyo nasulat? Or hindi ko lang nakita?
Na-remove ko po, ma'am. Meron po yan sa spread.
Sige daw. Sige daw, you check first if all the possible mole ratios have been included there sa inyong answer. It's the instruction, all possible. So you really have to write all the possible mole ratios.
Ayan po, ma'am. Okay na po.
Okay, pwede ko daw. Wala po nag-antipara. I hate wearing my antipara now. Sige, pwede ko. Ayan, palakihin niyo din ang slide mismo. I-present niyo daw. Okay. So, ganito class. You have there 4 moles of ammonia and the NO, and then the vice versa of this, ha? So, you may also write moles here of NO is to 4 moles of ammonia. Okay? And then ammonia and N2, this is it. So, ito yung kanyang reciprocal. And then ammonia and water. Where is that? Wala. Wala din ito. So let's just write it. 4 moles of ammonia also is to 6 moles of water, and the vice versa, 6 moles of water is to 4 moles of ammonia. Ayan. And then after that, let's delete this. After the ammonia, we may have the NO. So NO and N2, this is it. And ito yung kanyang reciprocal. And then NO and water. Wala. This one, 6 moles of water is to 6 moles of NO. And yung kanyang reciprocal. Balik na rin lang natin siya. 6 moles of water. Okay? And then, we are done with the NO. Let's have the last one. N2 and water. So this is it. And this is the reciprocal. Okay? So, sa lahat, since the instruction is all possible mole ratios, you really have to write everything, ha? Isa-isahin ko din yan siya magpag-check doon sa inyong submission, and I'll be giving points for that. Each of the mole ratios na possible dyan sa equation. Medyo marami kasi you have 2 products and 2 reactants, and you have to consider also the reciprocal of that. Kasi possible pa rin yun siya. Okay? Questions about this?
Gila man to niya ilatibil.
Sa daw? Ano sa dato? Who is that?
Sabi ako gula.
Crystalline, imuhang mic.
Okay. Sige, walay. Walay pangutana. Walay pangutana. Sige, next. I'm really not feeling well. Analyze and solve the problem. Okay lang. Akurat lang. Sabi ko, nasuko na kaniya, Crystalline. Okay. What was the problem again? Let me read first the problem. Pakibalik daw sa previous slide. Ammonia is widely used as a fertilizer and in many household cleaners. How many moles of ammonia are produced when 6 moles of hydrogen gas react with an excess of nitrogen gas? Take note, class, we have the Birchnough, right? This one are the diatomic molecules, and that hydrogen gas is included here. So this will become H2, and so does nitrogen. So this is also N2 here. So you will have NH3. Okay, paki-next daw. Pwede din namang baliktad. N2 plus H2 plus equals ammonia. Parehas lang naman yan. Pero this one is not yet a balanced equation. So, well, let's see. Ano yung balanced equation ninyo? 3H2, that's 6, N2, and okay. So this one is the balanced equation. 3 moles of hydrogen plus 1 mole of nitrogen will yield 2 moles of ammonia. And then the given is 6 moles of hydrogen. So, gaano daw karami na ammonia yung mapuproduce if you only have you have 6 moles of hydrogen. So this one is just using our pattern, pero sa part ng pattern na gagamitin ninyo, dito ka lang magsa-start. Wait lang ha. So dito ka lang mag-start. Pero this one, hindi mo na kailangan si molar mass because the moles is already given. So just multiply it directly to the mole ratio. So you have 6 moles of hydrogen. Our mole ratio, sa baba yung mole ng hydrogen para ma-cancel. And sa taas yung hinahanap natin, which is the moles of ammonia. So based on the balance equation, this is 2 moles of ammonia is to 3 moles of hydrogen. So 6 times 2 is 12 divided by 3. The correct answer is 4 moles of ammonia. Okay, that's again the correct answer. Any question for this problem? Wala. Sige. Next, I think this will be the last one. The decomposition of potassium chlorate is used as a source of oxygen in the laboratory. So, how many moles daw of potassium chlorate are needed para makaproduce tayo ng 15 moles of the oxygen gas? Let me see your equation. This one is decomposition. So, you will only have one reactant. You have potassium chlorate decomposing, yes, to potassium chloride plus the oxygen. And for the balanced equation, that's 2 KCl. Let me rewrite it para makita nila sa screen while we are discussing the solution. Again, you have KClO3 yielding potassium chloride plus oxygen. So you may write here 2 3, and 2. So this one is already balanced. Now, the question is how many moles of potassium chlorate is needed para makaproduce tayo ng 15 moles ng oxygen. So moles to moles pa rin, which means we only need to multiply the moles to the mole ratio. So our mole ratio here is 3 moles of oxygen ang mapuproduce kung meron kang 2 moles of potassium chlorate. So 15 moles of oxygen, cancel ito, you will get moles of potassium chlorate. 15 times 2, that's 30 divided by 3. Okay, so this is 10 moles. So kailangan natin ng 10 moles of potassium chlorate to produce 15 moles of oxygen. So that is number 2. You just have to identify the reactants and the products in the given para mabuo mo yung equation and you can solve for the unknown in the problem. Okay? Is this the last one? Tama ba ako? Last na ito. Meron pa bang next? Sige daw, in-next mo daw. Parang wala na. Wala na, no?
Wala na po, ma'am.
Conclusion na lang siya. Okay. So I hope you learned something from this activity or yung nakapractice kayo since we are done with this in the lecture. You just have to read carefully the problem and identify again the reactants and the products. Again, do not forget how when you are going to solve for a stoichiometry problem, the first thing that you need to ensure is meron kang balanced equation. Okay, questions or clarifications? Wala. Sure na?